Okay, I'm going to start section 11.3 now, which is working with quadratic functions. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not zero. Okay, so we've already done a little bit of this, right? In section 10.2, we looked at it. Also in 10.4, I mean, we're graphing quadratic equations. All right, so in problem 18, the most basic quadratic function is y equal x squared, or f of x equal x squared. That means the same thing. This function is sometimes called the square function, and I've got a sketch of the square function, so I'm just using a table of numbers. Okay, if I plug in 0, 0 squared is 0, so here's 0, 0 on the graph. If x is 1, 1 squared is 1, so here's 1, 1 on the graph. If x is negative 1 squared is 1. So here's negative 1, 1 on the graph. If x is 2, 2 squared is 4. So here'd be 2, 4 on the graph. And then if x is negative 2 squared is 4. And so here's negative 2, 4 on the graph. And I'm drawing a parabola. A quadratic is always going to take the shape on of a parabola. Okay. And so this would be the most basic parabola. State the domain and the range. Okay, the domain would be all real numbers. In other words, I can square any number I want. Okay, the range is all non-negative numbers. I know if I square a number, I'll never have a negative coming out of the calculation. Of course, I can get that from the picture also. Okay, now let's go to problem 19. Part A, the graph of g of x, which is equal to x squared minus 4, is shown to the right. That's this guy here. Okay, now one way to obtain this graph is to apply a shift of the graph of the square function down by 4 units. Okay, if I shift this graph down 4 units, I get this graph here. Part B, state the domain and the range of g of x. Well, the domain is all real numbers. Okay, I can square any number I want and then subtract 4, right? There's no problem with that. The range would be negative 4 to infinity. And of course, I can get that from the graph, right? If I'm at negative 4 or bigger on the y-axis, and I look to the left or the right, I'll be on this parabola. Okay, part C. Suppose that we would like to shift the, graph the equation y equal x squared plus 4. Okay, one way to obtain this graph would be to apply a shift of the graph of y equal x squared up by a distance of 4 units. Okay, so like what caused the graph to go down 4 units? Well, it's the minus 4 that we see, right? If we had a plus 4, it would go up 4 units. In general, if we want to graph a function, here I'm using the square function, but actually this statement applies to any function, and you add a constant at the end, we can start with the original graph of y equal f of x and then shift k units up if k is a positive, and then k units down if k is a negative. So like in this problem, k is negative 4, okay, and you had to shift the parabola down 4 units. Here's problem 20. Okay, part A, the graph of h of x equals x minus 4, the quantity squared, is shown to the right. That's this graph here. One way to obtain this graph is to apply a shift of the graph of the square function to the right by 4 units. Okay, if I just shift this graph to the right 4 units, I get this graph here. Now what caused that? Well, it's the minus 4. Okay, and we'll look at that in just a moment. State the domain and the range of h of x. The domain would be all real numbers. Okay. Again, you can square anything that you want. The fact that I've got a minus 4 there doesn't matter, right? I can take any number, subtract 4, and then square the result, right? I can do that to any number I want. The range would be 0 to infinity. So by squaring anything, I will never have a negative coming out of that calculation. And of course, I can also get that from the picture here. Part C, suppose that we would like to graph y equal x plus 4, the quantity squared. One way to obtain this graph is to apply a shift of the graph of the square function to the left by a distance of 4 units. So what caused the square function to go to the right 4 units? Well, it's this minus 4 here. Okay, if I had a plus 4, the parabola would go the other way 4 units. Okay, from this graph, it'd go 4 units to the left. Okay, part D. In general, if we want to graph y equal f of x plus k, and essentially what I'm doing here is I'm starting with y equal x squared, but I'm just replacing x with x plus k. All right, now in this problem, k is a negative, and whenever k is a negative, you're going to shift to the right that many units. If k is a positive number, like here, k is 4, you're going to go to the left that many units. Now that's kind of backwards from how we want to think of it. We kind of tend to think k positive, I go to the right, k negative, I go to the left, but it's switched on us. Okay, k positive means that you're going to go to the left. K negative, like what we see here, means that you're going to go to the right that many units. On the next page, so we have seen previously in the last chapter that the graph of a quadratic function is a parabola. Okay, now sometimes a quadratic function is written in this like alternate form. Ax squared plus bx plus c, we sometimes call that the standard form. And then this other form here, a times x minus h squared plus k, we sometimes call that vertex form. The graph of this function is also a parabola. Okay, it's just written in a different form. The vertex is represented by the point v equals hk. So one reason why we call this vertex form is because we can easily get the vertex just by identifying what is h and what is k. You see, what we were doing in chapter 10 was we had to first compute x equals negative b over 2a, and then once we had that number, we could then find our y coordinate. That's just because we were in the standard form. Okay, if we're in the vertex form, we can get the vertex quicker than that. Okay, and just as before, the value of a will tell you if the parabola is going to open up or down. Okay, a positive means that the parabola opens up. A negative means that the parabola opens down. Let's take a look at problem 21, part A. State the horizontal and or vertical shifts that would be applied to the graph of y equal x squared to get the graph of f of x. Okay, the minus 4 that we see at the end there, that means that we're going to go down 4 units, right? That's what I was talking about in this problem. Okay, this parabola is going to go down 4 units if you have a minus 4 there. The plus 3, the plus 3 would mean that you're going to go to the left 3 units. Okay, k positive means that you're going to go to the left 3 units there. Okay, and so if you can imagine just starting off with this parabola here, and then going down 4 units and to the left 3 units, we're just simply going to relocate this parabola is all. Okay, so in part B, we're going to graph the parabola. Okay, we'll determine the vertex, the intercepts, and whether the graph opens up or down. All right, so A is 1 in this problem here. That parabola is going to open up. The vertex would be represented by the point hk. All right, now the way to think of this is x minus negative 3. Okay, h is the number that you're subtracting from x. So I would be subtracting negative 3 to get this to be a plus 3. H is negative 3. K is just whatever number is after the squared part, which for us is negative 4. Okay, so the vertex in this problem would be located at negative 3, negative 4. Okay, and I've got that point plotted right here. Then I want to find the intercepts. Okay, so to get the x-intercepts, let y be 0. Y and f of x mean the same thing, so I need to let the function be 0 and solve for x. That's what I've got here. I'm letting the function be 0. If I add 4 to both sides and then take the square root of both sides, don't forget about the plus or minus when you take the square root of both sides, subtract 3, Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. Okay, so this parabola is going to cross the x-axis at negative 1, 0, and then negative 5, 0. To get the y-intercepts, we need to let x be 0. Well, that just means I got to plug 0 into the function, and so I've done that here. 3 squared is 9, minus 4 is 5. Okay, 0, 5, that would be this point right here. That would be where it crosses the y-axis. And now that I've got 4 points to work with here, the vertex and these 3 intercepts, I can then draw on the parabola. And you'll notice that really all we've done is we've started with this basic graph, y equal x squared, and we've shifted it down 4 units and to the left 3 units, right? If I move down 4 units into the left 3 units, then here's what I'm looking at, okay? Now part C, state the domain in the range of f, okay? The domain is all real numbers, right? You can see that from the graph, or you could take any number, add 3, square the result, and subtract 4, right? You can do that to any number you want. The range would be negative 4 to infinity. Okay, I can see that from the picture. If I'm at y equals negative 4 or bigger, and I look to the left or the right, I'll be on the parabola. If I'm less than negative 4, there is no graph less than negative 4 here, okay? Negative 4 to infinity. Why don't we take a look at, we'll do one more here in this video. So problem 22 is just another example, a similar deal. Okay, state the horizontal and or vertical shifts that are applied to y equal x squared to get the graph of f of x equal x minus 2 squared minus 5. Okay, so the minus 5 means that I've got to shift y equal x squared down 5 units, and then the minus 2 means that I've got to go to the right, since that's a minus 2, go to the right 2 units. Okay, so I'm going to start with this graph. I'm going to shift down 5 and then go to the right 2 with all the points. And that movement then would get me my new graph here. Okay, we're basically just relocating y equal x squared is all. Part B, okay, now we're going to graph this function by determining the vertex, the intercepts, and whether the graph opens up or down. Well, a is 1, that's a positive number, so the parabola opens up. We're in vertex form here, so h is 2, and k is negative 5. 2, negative 5, okay, that'd be the vertex. And of course, I can also know that right away by, knowing that if I start with 0, 0, and I go to the right 2 and then down 5, well, that's going to put me at 2, negative 5 then, right? Get the intercepts now. So if you set the function equal to 0 and solve for x to get the x-intercepts, let's see, we got to add 5. We'll take the square root of both sides and then add 2. 2 plus root 5 would be 4.24 roughly, and then 2 minus root 5 is negative 0.24 roughly. Okay, so on the x-axis I need to plot a point at roughly 4.24, that'd be about right here, and then also another point at roughly negative 0.24, that'd be about right here. To get the y-intercept, I need to let x be 0. Or I just need to plug 0 into the function is all. Negative 2 squared is 4, minus 5 is negative 1. Okay, so here's 0, negative 1, where the parabola will cross the y-axis. So I've already got the vertex plotted there at 2, negative 5, and then I just plotted these 3 intercepts. And so working with these 4 points, now I can then draw on the parabola. Passing through those points. And of course, like what we were doing before, when you draw on a parabola, we want a nice smooth turn through the vertex. Don't make it look like a V-shaped graph or anything like that, okay? And then also, it should be symmetric on either side of the vertex, okay? They're not asking us to graph the axis of symmetry, okay? But of course, that's a feature of a parabola, is that it's going to look the same on either side of that axis, that the vertex there. Part C, state the domain and the range of f. Okay, so, I can square any number and subtract 5, right? Domain is all real numbers. By the way, the domain of any quadratic will always be all real numbers, okay? Just a heads up on that. The range, okay, from the picture here, it looks like if we're at -5 or bigger on the y-axis, and we look to the left or the right, we're going to be on the parabola. There is nothing below the vertex here, so there's nothing below -5, right? -5 to infinity would be the range of the function. Okay, and we'll stop the video right there.